Alright, so welcome to the fourth video on radical expressions and equations. Today we're going to be talking about how to add and subtract radicals, and we're going to talk also about the conjugate. But before we get started, what I want to do is start by talking about sort of like, I don't know, a second grade math problem. So here we go. Jake has 2 apples and 3 oranges. Joe has 5 apples and 1 orange. How many apples and oranges do they have together? And so you see down below I drew some apples and oranges, and you knew from a super young age that when you wanted to count these, you counted the oranges. You counted the oranges totally separate, right? We move our orange over, and you count the apples totally separate, right? Because they're different. And so the answer you would get is 4 oranges and 7 apples because you put them in their appropriate piles. It turns out that lots of things are this way. So let's look at this related question. So you have 3 $5 bills and 2 $10 bills, and your sister has 4 $5 bills and 1 $10 bill. And the question is, how much do you have together? And you could compute how much you have by multiplying the number of $5 bills by how many of them you have, and adding the number of $10 bills you have times $10. And your sister has 4 $5 bills, so you would multiply them, and 1 $10 bill. But if you write the 3 $5 bills and the 4 $5 bills together, you really have 3 plus 4 $5 bills between you, and 2 plus 1 $10 bills between you, right? And so you have 7 $5 bills and 3 $10 bills, which is 35 plus 30, which is $75, right? And so you can think of the $5 bills and the $10 bills just like the apples and the oranges in our previous example. What you want to do is you want to pile like things together and count them before doing anything with them. And so that brings us to the actual topic today, which is what do you do when you have something like 3 radical 5 minus 2 radical 5. Well, let's do plus first. So here you want to think of the radical 5s kind of like oranges, right? If you have 3 of something and then you have 2 more of something, so if you had 3 oranges plus 2 oranges, you'd say you have 5 oranges, right? You add the numbers in front here, right? And then you tell me the things that you have. So you'd say you'd have 5 radical 5s, right? And this is important because if we go back to our original question here, Jake has 2 apples, 3 oranges, Joe has 5 apples and 1 orange, right? If instead of apples and oranges we had some radicals, suppose we had, Jake has 2 radical 3s and 3 radical 5s, and Joe has 5 radical 3s and 1 radical 5, right? Well, over here he'd have his 7 radical 3s and our 4 radical 5s, right? And so when we added everything together, we would add the radical 3s to the radical 3s and the radical 5s to the radical 5s, just like we would keep oranges with oranges and apples with apples. Another way to think about this is if you had 3x plus 2x, remember, you would add them by adding the coefficients in front and get 5x. And so in this way, the radicals are almost being treated like a variable. So let's see what happens when we try to add radical 5 plus radical 2 to 3 radical 5 minus 4 radical 2. Step 1 is to write like terms next to each other. Alright, so here we have radical 5 plus 3 radical 5 plus radical 2 minus 4 radical 2. Now remember, if you just have something like a radical 5 or a radical 2, that's really one of them, right? Just like when you have x by itself, it's really 1x. And so all you have to do is combine the numbers in front, like that. And there's the 1, there's the negative 4, there's the 1, there's the 3. And the answer you get is 4 radical 5 plus negative 3 radical 2. And a slightly nicer way of writing that is 4 radical 5 minus 3 radical 2. Now, we can tell that radical 5 and radical 2 can't combine because both of those numbers are prime. But here's an example where that's not always the case. What if I asked you to do radical 8 plus radical 2? You might initially think, okay, so my radical 8s are my apples and my radical 2s are my oranges, and so they don't combine. And here's where sort of the trickery of radicals works. 8, remember, is 4 times 2. And so radical 4 times 2 is radical 4 times radical 2, which is 2 radical 2. And so this can become 2 radical 2 plus radical 2. And you remember the 1 out front. And so if you have 2 of something plus 1 of something, you have 2 plus 1 radical 2's, which is 3 radical 2. And so this is something that you definitely have to watch for when you are adding and subtracting radicals, is that some of the radicals will reduce to be the same type of radical as others. And so you must always reduce first, and then finally you can add or subtract things. So let's do another one. Let's do radical 50 minus radical 32. And so 50 is 25 times 2, and 32 is 16 times 2. And so what you're going to get is radical 25 radical 2 minus radical 16 radical 2, which is 5 radical 2 minus 4 radical 2, which is 5 minus 4 radical 2, and that's just radical 2. And so our answer is radical 2. Now, the next thing we need to do is remember how to FOIL. Right? If we take two terms and we multiply them, we have to do 4 multiplications. We get a times c plus b times c plus a times d plus b times d. Right? So whenever you FOIL, you get 4 terms. 1, 2, 3, 4. Every time you FOIL, you get 4 terms. And so let's try multiplying things that happen to have radicals. 1 plus radical 3 times radical 2 minus 4. So we have our 1 times radical 2, and so that's 1 radical 2 plus radical 3 radical 2 plus 1 times negative 4 plus radical 3 times negative 4. Now, we have to sort of go step by step and reduce all these to things that we can work with. 1 radical 2 is just radical 2. Radical 3 radical 2 becomes radical 6 because 3 times 2 is 6. 1 times negative 4 is just minus 4. And radical 3 times negative 4 is minus 4 radical 3. Now, what we have going on here is radical 2, radical 6, and radical 3 actually have nothing in common. So none of these can be combined. And since none of them can be combined, all of this is just stuck the way it is, and this is a good final answer. Let's try another one. 2 minus radical 3 times 3 plus radical 3. First we do 2 times 3, which is 6. Then we do 3 times negative radical 3, which is minus 3 radical 3. Then we do 2 times positive radical 3, which is plus 2 radical 3. And then we do negative radical 3 times radical 3. Now, let's talk about this first. Remember, whenever you multiply a radical by itself, you get what's underneath. So that actually just becomes minus 3. 6 stays the same. And then we have minus 3 radical 3 plus 2 radical 3. Now these radical 3's are the same, so we can just combine the coefficients. And so also 6 and 3 are both just integers, so we can go ahead and combine them too. We get 6 minus 3, which is 3, plus 2 minus 3 radical 3, which is 3 minus radical 3, because that is negative 1. And so we multiplied these two things, and we just got 3 minus radical 3. Now, if you notice what's going to happen next, when we multiply these two, we get 2 times 2, which is 4, minus 2 times radical 3, plus 2 times radical 3, minus radical 3 times radical 3. And what we get, due to this, right, see how we have 2 radical 3 and negative 2 radical 3, they cancel. And so we're left with 4 minus, and then radical 3 times radical 3. Whenever you multiply a radical by itself, you get what's underneath, 4 minus 3, which is just 1. And so we multiplied these two expressions, and all of the radicals disappeared. And so here's a little fact. If A or B has a radical, A plus B times A minus B will have none. And the reason is, you should recognize this from factoring. A plus B times A minus B is A squared minus B squared. Right? And so if A has a radical, A squared won't. And if B has a radical, B squared won't. And so if you have something with a radical, you can multiply it by either A plus B or A minus B to get rid of the radical. And so remember, one of the rules, we don't want radicals in the denominator. And so when we had something like 2 over radical 5, we multiply top and bottom by radical 5, and the top becomes 2 radical 5, and the bottom becomes 5, right? But now it's possible to have radicals in a less friendly way. Radical 5 minus radical 3. And now you can't just multiply top and bottom by radical 5, because it won't get rid of the radical 3. And you can't multiply top and bottom by radical 3 because it won't get rid of the radical 5, but we can rely on this. If a or b has a radical, then a plus b times a minus b will have none. So here is, right, this is our, you want to think of this as a minus b. And so what you want to multiply it by is a plus b. Right? But you got to remember to multiply the top as well. And so the bottom, right, remember the bottom becomes a squared minus b squared. And if a is radical 5, then this is radical 5 squared minus radical 3 squared. And the top is just 1 times radical 5 plus radical 3. And so let's drop that back down. We have this as the most recent calculation, and so the top becomes just radical 5 plus radical 3, and the bottom becomes 5 minus 3, and we get rad 5 plus rad 3 over 2. And so we got no radicals in the denominator. Let's try another one. Let's do radical 2 over radical 5 plus 1. So again, this is going to be like our a plus b, and since we have a radical, we're going to need to do some work. We're going to need to multiply by a minus b, and so that's radical 5 minus 1, radical 5 minus 1. And when you do that, on the bottom you get a squared minus b squared, and so you get radical 5 squared minus 1 squared. And on the top you get radical 2 times radical 5 minus 1. Now, dealing with the top, if we distribute, right, because we always have to distribute, we get radical 2 radical 5 minus 1 radical 2. On the bottom we get radical 5 squared is 5 minus 1 squared is 1. Now, these two are being multiplied, so we multiply underneath, and 2 times 5 is 10, minus radical 2 all over 4. And so that's it. We can now clear out denominators by multiplying. If we have a plus b, we multiply by a minus b, and if we have a minus b, we multiply by a plus b. A plus b and a minus b, they have a funny name. They're called conjugates. And we use them all the time in math. Almost always to do things like clear out a radical or clear out an imaginary number or things like this. And so the things that I want you to remember from today's lesson are radicals, just like variables, are like apples and oranges. They can only be combined when they're the same type, and so you can only add or subtract them if they reduce to the same type of radical. And then when you multiply expressions, you have to remember to use FOIL. And then there is a very fancy thing called the conjugate, which allows us to get rid of difficult radicals in the denominator. And so that's it. This video went a little long, but there's a lot of information in this chapter, so I hope you practice the homework, and I'll see you in class.